class, so we are here to talk about perpendicular and angled bisectors. So really fast, I want to review what equidistant means. It literally means equal distance. So a point that is the same distance away from two objects. So 2 points, 2 segments, 2 lines, etc. You can even use this in your everyday language, like, oh, it doesn't matter what route I go to get to the gym, it's equidistant. It just means equal distance. So if I have 2 points, let's just say I have 2 points right here, and there is a random point here, and I say it's equidistant, both endpoints are equidistant to the orange point, it means that these 2 segments would be the same distance. If this is 5, this is 5. So these 2 points are equidistant from that orange point. So what we did in class was we kind of drew that perpendicular bisector, which as a reminder means that it's perpendicular, so a segment that is perpendicular to another segment at the midpoint. And the midpoint cuts the original segment in half, okay? And then we said, hey, no matter where you draw a point, if it's on the perpendicular bisector, no matter what, it is going to be equidistant to each endpoint of the original segment. Okay, so with that in mind, that's the conjecture. Here is the theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So here it says PM is the perpendicular bisector of AB. So here is PM, that is the perpendicular bisector. Once I know it's a perpendicular bisector, I should be marking that it's at the midpoint. So the 2 segments are congruent, and then also that it's a right angle, perpendicular bisector. And what this tells me is since point P is on the perpendicular bisector, it means that point P is equal distance away from the endpoints of the segment, A and B. So these little segments right here that I'm highlighting, AP, is congruent or the same distance as PB. So PA is congruent to PB. Okay, so what is the hypothesis and what is the conclusion? If a point is on the perpendicular bisector, comma, that's your hypothesis, then it is equidistant from the endpoints. That's your conclusion. Okay. The converse is also true. So if you know that 2 segments are congruent, if a point is equidistant from 2 endpoints, then the point lies on the perpendicular bisector. So if you know that these 2 segments are congruent, you are allowed to conclude, oh, so this must be the perpendicular bisector. So you could say those are congruent and it's perpendicular. So if DA is equal to DB, then CD is the perpendicular bisector, which I'm going to write perpendicular symbol and BIS for bisector, of AB. Okay, so the hypothesis is this part. The point is equidistant. And then the conclusion is that it's the perpendicular bisector. Okay. All right, so here's a couple examples. Starting with example A, it does say that given that MY is the perpendicular bisector of each triangle, then we want to solve. So we know that this is congruent to this because MY is a perpendicular bisector. So here's MY, and so AY, this guy, is going to be congruent to this y because it's a perpendicular bisector. And then also I know that this angle is a right angle. Now, since M is on the perpendicular bisector, it's like an isosceles triangle, okay? It's like we have an isosceles triangle. So I can set these two equal to each other. 3x minus 4 equals 2x plus 10. So I get x equals 14. All I did was subtract over the 2x. 3x minus 2x is 1x, and then I added over the 4. 10 plus 4 is 14. Same thing here. This time, MY is the perpendicular bisector, so this segment DY is congruent to YC, meaning I can set these equal. So 2x plus 9 equals 4x plus 3. So let's see, I'm going to subtract this 3 over and move over the 2x, just kind of showing my work. So I get 9 minus 3 is 6 equals 2x, so x is 3. And then I also know that since M is on the perpendicular bisector, that these two sides are also congruent because it's equidistant from the endpoints. So I know that 3x plus 2y equals 5x plus y. Well, hold on, I just found out that x is 3. So let's plug in 3 for x here and 3 for x there. So 3 times 3 is going to give me 9 plus 2y. 5 times 3 is 15 plus y. So let's see, if I subtract over y and over 9, I get y equals 6. Perfect. Okay, last thing, it says draw the perpendicular bisector of AB. So AB is the one I want to be cut in half. You have to mark that it is the midpoint and make sure it kind of looks like it's the midpoint. And then just draw a perpendicular line through it. And you also have to mark that it is in fact perpendicular. Draw the perpendicular bisector of EF. So I find EF, I draw a midpoint. You have to mark it that it's a midpoint, and then draw a perpendicular line right through it. You got to mark that it's perpendicular. And then the last problem here is going to be draw the perpendicular bisector of GH. So find GH, find about the midpoint. That looks a little bit off, so I'm going to adjust it this way just a little bit. You want it to look like it is in fact a midpoint. And then again, you want to draw what looks perpendicular. It's not going to be perfect always, but we want it to look perpendicular. And there it is. So it might look a little bit different depending on which side we're drawing it to. All right, so that is all the perpendicular bisector stuff. We're going to move on to angle bisector next. So this part is going to talk about angle bisectors. So just like the name angle bisector, an angle bisector is literally a ray that bisects an angle. So it cuts an angle in half. So let's just take a quick look at this picture right here. So it tells me in the words that AD is an angle bisector of the whole angle, BAC. What that means is that these two little angles are congruent. So angle BAD is congruent to DAC. Now, there's also a theorem, the angle bisector theorem, that says if a point lies on the angle bisector, like this point D, then it's equidistant to the sides of the angle, okay? And I could draw another one. I could draw a point right here. And the shortest distance from a point to a side, notice like this, I'm just taking this, the point to the side, the shortest distance, here's a longer distance, but the shortest distance is when it's perpendicular, Okay, so that is why you see those little perpendicular marks. So if I draw two segments that are each perpendicular to a side of the angle, then these little segments are going to be congruent, which is exactly what it says in the theorem. So in this one, if I know that there's an angle bisector, then segment BD is going to be equal to segment CD. Those are going to be congruent. And the reason the perpendicular marks are there are just to prove, hey, this is the shortest distance. So these are the two distances that are equal. So if the measure of angle BAD is equal to the measure of angle CAD, in other words, the little angles are congruent, then those segments are congruent because the point D lies on the angle bisector. So the hypothesis is that there's a point on a bisector. If that is true, then that point is equidistant to the sides of the angle. The converse is also true. So if I know that these segments, which are the little distances from a point to the sides of an angle, if I know that these are congruent, then what that tells me is that this AD must be the bisector, and therefore these angles are going to be congruent. So BAD is congruent to DAC, which is what I wrote here. Okay, so this time the hypothesis is the opposite. If a point is equidistant to the sides of the angles, then that point is on the angle bisector. If you want to pause the video and write down these notes, feel free to do so right now. And if you paused, we can now move on. So example 3 says, find the missing side length or angle measure. Each problem does not relate to the next. So it says if JL, so we're going to use this image for both problems, or for all problems. If JL, you know what I'm going to do, you guys? Look at this. If you're on your iPad, you can do this too. We can copy, paste the image. I'm just going to make it smaller so we don't get confused. So for the first problem, if JL bisects angle HJK and LK is 11.4, find LH. So let's talk about this. Okay, oops. It says that this is an angle bisector. Okay, so that means these little angles are congruent. And then point L is on the angle bisector, so that tells me that these sides are congruent. It also tells me that LK is 11.4, so that means that LH is 11.4. So that's the answer to this problem. I'm going to paste the image again. So now, if LH is 26, so this distance is 26, we're starting over, so we don't know for sure if this is an angle bisector yet, okay? It also tells me, though, that LK is 26, so now I know that these two segments are congruent. So now I can conclude that, yes, this is an angle bisector, okay? So now I'm going to mark, since those are equidistant, that can conclude that these are angle bisectors. And let's see, it tells me that HJK, this entire thing, is 122 degrees. This whole thing. So if that's 122 degrees, all we want to do is divide it in 2 to get the angle bisector. So each of these little angles are 61 degrees. What does it ask for? LJK, which is this angle, and that's 61 degrees. Okay, last one. I'll use the big image to do the last one. Okay, so this one says if LH is equal to LK, Okay, if those are equal, then I know that this is a bisector. So I'm also going to mark these congruent. Okay, it says HJL. Okay, this is kind of poorly labeled. I know that's happened before. I believe H should be this. So HJL, that angle, is 3y plus 19. LJK, that's LJK, this angle is 4y plus 5. So since these sides are equal, the angles are equal, and I can set these equations equal and solve. So let's see, I'm going to subtract over 5. So I get 14 equals, I'm going to also subtract over 3y, and that's actually the answer for y. What is it asking me to solve? It says find the value of y. Y is 14. So there's 3 examples of algebra problems with angle bisectors. And finally, this last part is very quick. Just draw the angle bisector of different angles. So if it wants the angle bisector of A, then you want to draw something, a segment. I'm going to just connect it to the other side. But look, you want to make it look like it's cutting that angle A in half. So I would say maybe right about here. That's a total estimation. I'm going to mark that these are congruent to prove that it's an angle bisector. And we're just going to eyeball it. All right, but make it look somewhat accurate. This time we're going to do the angle bisector of F. Okay. So again, we want to make it look like it's actually the angle bisector. I would say that's like right here. And last, but certainly not least, the angle bisector of I. So for this one, let's see, man, this looks kind of like it would be right here. And that's it. So an angle bisector just cuts an angle in half, and then we also have that theorem about a point on an angle bisector being equidistant to the 2 sides of the angle. Hopefully that makes sense. Hopefully the whole lesson makes sense. But as always, if you have questions, come with them on Monday, ready to ask. And your task today is to do worksheets 5 if you did not do that last night, and also worksheet 6 over the weekend. I'll see you Monday.